All right, in this video, we're just going to talk about how to prove that a figure is a parallelogram using a few formulas that you may be familiar with. So just if you are familiar, the slope of a line is going to be rise over run. Generally, we call that the change in the y divided by the change in the x. So you may be familiar with it like this. Y is just going to be the the slope, call that m, is the change in the y, or y2 minus y1, divided by the change in the x, x2 minus x1. And that'll help us solve for proving that opposite sides are the same, going in the same direction, so they're going to be parallel. We're going to also use the distance formula. The distance formula is a subset of the Pythagorean theorem, and it's basically the square root of the change in the x squared plus the change in the y squared. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And then finally, the midpoint is just the coordinate. It's the average of your x's. So x1 plus x2 squared, comma, the average of your y's, y1 plus y2 squared. We're going to use these three formulas to help us prove that a quadrilateral is a parallelogram, other than just by looking at it, okay? And we can look at a problem and say, yeah, it's going to be a parallelogram. I do have a typo on this one. That's actually supposed to be a 4. So the first thing we're going to do is we're going to plot this coordinate, all 4 coordinates. So coordinate A is negative 4, 4. Coordinate B is 2, 8. Coordinate C is 3, 4. That's a typo on there, so that should be a 4. And then coordinate D is negative 3, 0. And if I were to make a shape out of that, it's pretty convincing parallelogram. However, you can't really just say, hey, it's a parallelogram and expect to get marked right for it. You have to show using one of these formulas. So I'm going to show you 3 different ways to do it in the next couple slides. So the first example, we want to show that a quadrilateral is a parallelogram using slopes. Well, in order to do that, we're going to look at the opposite sides. Okay, so we have side AB. We want to show that it's a parallelogram. Slopes imply that the opposite side should be parallel. So we have to show that. In order to do that, that means the opposite slopes should be equal. If that's the case, then the opposite sides are parallel. All is good. You have a parallelogram. You have to show that for both pairs. Otherwise, it's just a trapezoid. Both pairs. So I'm going to start with the slope of AB. Well, it's going to be y2 minus y1. So let's see. We call it 8y2, 4y1, 8 minus 4, over x2 minus x1, over 2 minus negative 4. And that's going to be 4 over 2 minus negative 4 is actually 2 plus 4, so 4 over 6, which is 2/3 if you reduce it. And you can do a little rise over run to prove that it's 2/3. Up 2 and over 3, 2/3, 2/3. So my slope is 2/3. Now the trick is, I need to go to the opposite side and find that slope. So I'm going to do the slope of CD. And I'm going to call this one y2. So 4 minus 0. And my x2 and x1 is going to be 3 minus negative 3. Well, once again, that's going to be 4 over 6, which reduces to 2/3. So I've shown that those two pairs are parallel. I have to do the other set now. We'll do the same thing with AD and BC. So if I do the slope of AD, that's going to be, let's see, we got to call one of them 2, so we'll say 0 minus 4. It's important to go in the same direction. So if I do 0 minus 4, I have to do -3 minus -4. And that's going to be -4 divided by -3 plus 4. So 1. And that would just reduce to -4. Do a little rise over run. It goes down 4 and over 1. So -4 over 1. -4. And let's finally find the slope of BC. Looks like it's going to be -4 over 1. Let's just verify it here. I'll call this y1 and x1 now. 4 minus 8 over 3 minus 2. That's going to be -4 over 1, which is -4. So now what do I say? I say parallel, sorry, we say ABCD is a parallelogram. Opposite slopes are equal. Therefore, opposite sides are parallel. So you have to provide a reason. There is my reason. Symbolically, opposite slopes are equal, therefore opposite sides are parallel. We prove that with our math over here, so I don't have to do anything additional for that. On to the next one. How do I show that a parallelogram is a parallelogram using distances? Well, in this case, I have to show that opposite sides are congruent. So distances implies that opposite sides have the same measure, are congruent to each other. So I'm going to have to use the distance formula for all 4 of these. So the distance, we'll say D for A to B. And we're going to plug in x2, y2 again. I'm not going to label them this time. It's going to be the parentheses. Always do the x's together and the y's together. So remember the distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then put that under the square root. Just make sure you keep your x's together and your y's together and use parentheses. All right, so it's going to be 2 minus -4 squared plus 8 minus 4 squared. Now I would encourage you guys to just not even bother with the square root. That's going to be 2 plus 4. That's going to be 6 squared. So 6 squared plus 4 squared. 36 plus 16 square root of 52. Just leave it as a square root. Let's go to the opposite side and do the same thing. So this is going to be the square root of 52. Let's go over here and do the same thing here. So the distance for CD. And I would say parentheses 3 minus -3 squared plus 4 minus 0 squared. Let's see, that's going to be 6 squared plus 4 squared. And I already know that's the same thing. So opposite sides are congruent for that one. Now let's do the same thing with the other. All right, the distance for AD. I know this is tedious, but this is how you have to do it. Square root of, let's see, -3 minus -4 plus 0 minus 4. As long as you use parentheses, it doesn't really matter what order you do it because you're squaring it. That's going to be -3 plus 4. That's 1 squared. And -4 squared. Always use parentheses. Squaring a negative, that's going to be positive. So it's going to be 1 plus 16 square root of 17. I forgot to write square root of 52 here, so we'll add that. And then over here, that should be the same thing. The distance for BC. Just plug your x2, x1, so square root of 3 minus 2 squared, and square root of 4 minus 8 squared. That's 1 squared, -4 squared. Same thing. So we have proven that both pairs of opposite sides are congruent. Therefore, it is a parallelogram. So let's write it up. ABCD is and I'm going to use the symbol for parallelogram this time. Both pairs of opposite sides are congruent. That's your write-up. Go ahead and jot that down, and we'll do our last part on here. Well, how do we do it using midpoints? Midpoints are all about the diagonals. So with midpoints, we want to show are the diagonals bisecting each other. That's what we want to show for using the midpoint formula. It's actually the easiest way out of all three of them. So what you're going to do is you're going to look at the midpoint of the diagonals. So I'm going to look at AC for a minute. All right, now I can kind of estimate where the midpoint is, but I'm going to go ahead and do it mathematically. So if I look at the midpoint of AC, that's going to be, remember the midpoint is x1 plus x2 divided by 2. It's the average of your x's. Y1 plus y2 divided by 2, comma, the average of your y's. And we write that as a coordinate. So it's going to be -4 plus 3 over 2, and then 4 plus 4 over 2. Well, that's going to be -1/2, -0.5 if you want to write that, and then 8 over 2, which is 4, because the average of 4 and 4 is going to be 4. So if I go to that coordinate, -1/2 and 4, that's going to be right there. That means these two segments are equal to each other. And so that coordinate should also be the midpoint of my other diagonal if I'm doing this correctly. So let's go ahead and make that diagonal. And we're going to find the midpoint of BD. So we're going to take our x values and add them together. -3 plus 2 divided by 2, and 0 plus 8 divided by 2. All right, that's going to be -1 over 2, and 8 divided by 2, which is 4. So -1/2, comma 4. Now what's the significance of this? Well, I know those are both equal since I got the midpoint, but I also know that the midpoint of both diagonals happens to be the same coordinate, which means that we found the coordinate for both diagonals as the midpoint. Therefore, the diagonals bisect each other since they're both crossing at that same point. So we've already proven that as a parallelogram based off of that property. So we're going to write it up. We say ABCD is a parallelogram since diagonals bisect each other. The thing about this one is that we only have to use the formula twice rather than 4 times for the sides and the slopes. All right, guys. Hopefully that's helpful for you. Thanks for watching.